Hi everyone. In this video, we will talk about interrupts with respect to computer architecture. So what is an interrupt? Interrupt is an event which requests the processor or instructs the processor to execute a specific function. This is called the interrupt service routine, which is written to serve that particular interrupt. So that is being written by again the programmers, and that is to serve that particular interrupt. So there are different types of interrupts. In this particular video, we are not focusing on the types of interrupts. However, they can be divided into hardware interrupts and software interrupts, or it can be internal interrupts and external interrupts. And likewise, there can be different categorizations. Now, if we talk about the instruction cycle, so when there are no interrupts, the instruction cycle is pretty simple. That is, fetch, decode, and execute. But we can compress that into two stages, fetch and execute. So this is the simplest of instruction cycles. So you fetch the instruction, execute the instruction, fetch the next instruction, and execute that instruction, fetch the instruction after that, and execute the instruction after that. So in order to do all this, the program counter contains the instruction to be fetched. So the processor will fetch that instruction from the memory and bring it to the processor, decode and execute, and check the program counter and fetch the next instruction from the memory. However, when there are interrupts, once you finish execution of a particular instruction, the processor will check if there are interrupts which are received already. If there are interrupts, it will go and execute the interrupt service routine or serve the interrupt. If there are no interrupts, it will come back and fetch the next instruction. So there can be interrupt enabled and disabled states as well. So if the interrupts are disabled, again, it will act as there are no interrupts. So once the execution completes of the current instruction, it will go fetch the next instruction, right? So again, this is not that complex. However, what you have to know is an instruction during the instruction cycle will not be interrupted by reception of an interrupt. It will wait until the finishing of the current instruction to serve a particular interrupt, right? So once you finish the execution of the current instruction only, it will go check if there are interrupts and go jump to the interrupt service routine. So we will talk about it in a while, right? Now consider this particular simple example. So don't worry about the difficulty of this program. So this is just a program and there are 4 instructions, and those 4 instructions are inside the memory. The memory addresses are 0591, 0592, 0593, and 0594. And this program can go on up until any number of instructions, right? So I don't know the length of the program. So this is the few instructions that I have captured. Now consider the program counter containing the address of the first instruction, which is 0591. And now the instruction at 0591 will be fetched by the processor and it will execute that instruction. And after execution of that instruction, the program counter will be incremented by 1, and then the program counter's value will be 0592, and the processor will go and fetch the instruction at 0592, and it will be this instruction, and it will execute that instruction, and the program counter will increment to 0593, and likewise it will go and fetch the next instruction and execute the instruction, right? So at each cycle, the program counter will increment by 1, 591, 592, 593, 594, and so on, right? Now, say for example, if there is an interrupt. Now say the interrupt occurs at the instruction 592. So when we are executing the instruction at 0592, that is the second instruction here, while execution of that instruction, an interrupt occurs. But while execution of that instruction, when an interrupt occurs, the processor will still not go serve the interrupt, because it will first finish the execution of the current instruction, which is at the memory address 0592, which has been fetched and being executed. So once the processor finishes the execution of that instruction, it will check whether there are interrupts. Yes, now there is an interrupt. Now it will jump to the interrupt service routine corresponding to that particular interrupt. Now, before you jump to the interrupt service routine, there are some important things to do. Why? Because now, say for example, you go to that interrupt service routine. So if you go to that interrupt service routine, that means the program counter will be changed to the starting address of that interrupt service routine. Then what will happen? Once you finish execution of that interrupt service routine, the program counter doesn't know how to come back to the current program, right? It doesn't know which instruction to be executed. Because of that, this program counter has to be saved somewhere before it jumps to the interrupt service routine, right? And along with that, context of the program, that means the value of the EAX register, value of the EBEX register, and like all the values which has been already saved while execution of the current program has to be saved somewhere, because while execution of the interrupt service routine, these values can change, right? So now, but the current program was having a different idea of those particular registers, right? Because of that, those particular registers, not only these registers, the status register, the stack pointer, and there are a lot of other important registers, those values has to be saved somewhere before you jump to the interrupt service routine. Now, let's say the interrupt service routine starts from the address 1004 and it will go to 1005, 1006, and likewise. Now, at cycle number 3, now the program counter will be set to 1004 and it will fetch the instruction from the interrupt service routine and it will execute that particular instruction, and the program counter will be incremented by 1. Now it will be 1005 in the next cycle and it will execute that particular instruction, right? So once you finish all the instructions of the interrupt service routine, then it will get the program counter's value, which is already saved somewhere, and that value will be restored at the program counter. So that will be 0593, the next instruction, and it will come back and start executing from this particular instruction, and it will execute the current program until the end if there are no other interrupts. But if there are other interrupts, of course, it will jump into the interrupt service routine. And one more thing, how does the processor know that you have to jump to this 1004 of this interrupt service routine? That is being determined by, there is something called the interrupt vector table. So at the interrupt vector table, the address that you have to jump to for a particular interrupt is saved. So we will talk about those things in a different video. The only thing that you have to know for now is that there is something called interrupt vector table, which manages where to jump when an interrupt occurs, right? So interrupt is an event and it will hold the execution of the current program and it will jump onto the interrupt service routine. And before jumping, it will save the context of the program and then it will execute the interrupt service routine. Once you finish execution of the interrupt service routine, it will reload the context from where it is being saved and continue the execution of the current program, right? So that is all about interrupts. Thank you. So see you in another video.